All right, we're going to start with similar triangles. We're doing 7.4. You have your note sheets in front of you. We have two things. We have similar triangles have two things. Just like similar polygons that we were doing before, they have congruent corresponding angles and proportional corresponding sides. So here we have some pictures of them. You don't have them on your note sheet, but that's not a problem. We write it the same as we were writing it before. We put that little tilde in the middle there for being similar, not congruent. And the order matters. So A goes with X. Those are going to be congruent. That's what we were stating right here. And since B is second, it's going to go second with the Y. And C is going to go last with the Z. So those are congruent. Now the corresponding sides being proportional, we can write a proportion. And here we go. Now, the cool thing is I'm going to show you how to mark these. You will not have marking for your assignment, but I'm going to show you how to mark them. If you, because we're going to, today, you're going to start doing some proofs with similar triangles. I know that's really, like, on your high priority of fun. But we're going to mark those like we were marking them congruent. We're going to mark them as proportional to each other. We're going to mark that AB goes with the XY, just like I showed down here. We're going to show that AC goes with XZ. AC goes with XZ. And we're going to show that BC goes with YZ. Just like I was doing if they were congruent. Knowing that their proportions reduce to the scale factor, okay? So I'm doing that so that you can see what corresponds to each other. That'll be helpful when we do some proofs later, okay? Questions so far? All right, there are two things that absolutely have to be there for triangles to be similar. Absolutely, the minimal amount of things that have to happen are two things, and here it is. This is one of your postulates or theorems in your that you wrote already. If two angles of one triangle are congruent to two angles of another triangle, then automatically the triangles are similar. I should have wrote the word similar at the end there. This is called the angle-angle similarity, or AA similarity. You have a box now on your paper where you can write your AA similarity. That you only need two. Once you have two, you automatically have a third angle. And once all three angles are equal,
can we just write AA similarity?
That's what you can, yes, and then mark them as such. All right, so if I had two triangles here, like you do on your paper, if you had angle A congruent to angle R, and then angle B congruent to angle T, how do I know that automatically, now that C and S are congruent? There's a theorem that tells us that if two angles are congruent, then automatically the third is.
Corresponding parts of congruent triangles?
That would only be if they're congruent triangles. Does anybody remember? It's called the third...
Triangle theorem?
Almost. Third angle theorem. Third angle theorem, okay? So really, this could be called the AAA similarity, but you don't even need that third angle, because if you get two of them, you automatically know the third. So this is angle-angle similarity. You could have a little triangle and a big triangle, and they could have the same angle measures. They're not equal, but they're similar to each other. All right. The next thing you could have, if you didn't have two angles, you could have this one. If an angle of one triangle is congruent to an angle of another triangle, and the sides including those angles are proportional, then the triangles are similar. So we have to have one angle and then the sides that are next to or that include that side. So for example, this 18 goes with the 6 and the 12 goes with the 4. What proportion would I need to check to see if these were similar? What proportion would I write? What over what equals what over what?
18 over 12.
18 over 12, I heard.
6 over 4.
6 over 4. I'm going to write it this way. You're going to get that, Heidi. Yes, I agree. I'm going to write it like this. 18 over on this triangle goes with the 6 on that one. And 12 on this one goes with 4 on that one. They'll both, this on this one right here will reduce to what?
3.
3. Both of them reduce to 3. That's good. This reduces to 3 halves. Okay. Some of those properties of proportions were used to get from here to here. I think it's like reciprocal. No, it's switching the means and extremes. Or in this, which one is this? Means or extremes?
Means.
Means. If we switch the means here, we'll have that one. Okay? All right? Proportion still works. So these are similar because we have a congruent angle and the sides that include that angle are proportional. All right? So that's another place for your box there. You have something there to put in it, your side angle, side similarity. And you might even put some numbers in there with those triangles that are on there and show the proportion if you want. It's up to you. All right, the third one. The third way to show that two triangles are similar have nothing to do with angles on this one. It only has to do with sides. If all the sides of two triangles are proportional, then the triangles are similar. If only one of them doesn't match, then you're out. So this is what I suggest that you do when you're checking. I would suggest that you make the long, the medium, and the short. The longest side first, the middle sides, and the short sides. So on this one,
Oh, so don't write like the congruent marks? We don't want like the congruent marks? Like
we're going to check for proportional right now, to check if it's proportional. So we won't, I'm not doing the triangle similarity. I'm checking if it's proportional. So this is our
But like how would we mark it in our box?
on there.
Yeah.
I would write side similarity,
Uh-huh.
and then you can put then over here on this box. I would make those marks. Yes.
Okay.
And so what I'm doing here, yes. So the long here, 14 goes with the long of 7 on here, right? So I would put a 14 here and a 7 there, right? The medium is the 10 and the 5, so I'm going to go 10. And the shorts are the 6 and the 3. That's what you're meaning, right? So I'm going to put the 6 and the 3. Do those all reduce to the same thing?
Yes.
What do they all reduce to?
2.
Yes. So if they all reduce to the same thing, they're proportional. And since we have side, we know that these are similar triangles. Questions so far? All right, let's see what your homework's going to be like. I'm going to just talk to you about number 1. Number 1 is that page that I told you you're going to have to print another one if you print a double-sided with these little pockets that I gave you. All right, I'm going to give you some suggestions on how you can do that. The intention was for you to have these pockets and then you glue them in the pockets. Now that's not going to work for this, so what you could do is glue them near the pockets if you want, or on top of the pockets. So, like number 1 over here, is this not similar? Is this a side, or an angle side, or a side?
Oh, wait, you mean the actual lesson?
All right, let's go to the lesson now. Number 2 right here. State if the triangle in each pair are similar. Yes or no. If so, we're going to state how they are and then write the statement. Are these similar? So we got to first check. We know that the angle's equal, so we could have side angle side, but we have to check if it's proportional. So what does the 49 go with and the 56 go with?
56 goes with 40.
the 56 goes with 40.
And
And
it doesn't matter which one we put on
the
top.
49 goes with
Does
35.
it matter which one we put on top?
No, you can do the reciprocal on both of those and be fine. Did that make sense, Rana? Okay. Remember, because reciprocal property says we can flip them, right? Another reason why Amy was asking me, why do I need to know those properties? Because if Nariah would have wrote the other triangle on top, it would have been the reciprocal property, and it would have still been okay. Okay? All right. So 49 over 35, I can take a 7 out of both, and I get a 7 over 5. And 56,
Oh, I'm doing it backwards. I was like, what?
I can take an 8 out of both, and I'll get
7 over 5.
very good. Are they proportional?
Yes.
Yeah.
Yes, because I got the same thing. So what's the reason? We have 3 reasons.
Side, side.
Say that one more time.
Side, side.
There's not a side. There's one other thing. It's one of these 3.
Side angle side.
Side, angle, side. Do you understand why we got the angle? Because of the... So another part of our answer is angle. And please do me a favor. Put angle, and put your little similarity. If you don't want to write the whole word. Angle, similarity. So if we have triangle ABC, it's similar to triangle what?
A T U.
B goes down to the 56, which we said went with the 40. Yep, TU, I agree. ATU.
Does it matter where we write like that? It doesn't, right?
No, it does not matter. Because you're the one grading it, so wherever it's easiest for you. I like to put all my things close. Okay. But that's just me. Okay. Questions about this? All right. Are those similar? I chose these on purpose because this is a really good brain exercise. These triangles are on top of each other, and I have difficulties with that. So I'm going to tell you what I do, okay? This is number 4. Number 4, I do this. I separate the triangles by drawing them. I redraw U, T, S. All right, then I'm going to redraw the little one. And L, S, M. Is there something that both of those triangles share in common? An angle or a side? S. You do know that angle S is congruent to angle S by reflexive if you were doing a proof. So we can mark that. Do we know... We said that's 28, and that one's 30. Does that help us to know anything about this triangle? What did we know that has to happen for triangles to be similar? 2 things. The sides have to be proportional, but the angles have to be what?
Congruent.
Are the angles congruent?
No.
So what do we know about this triangle?
It's not similar.
It's not similar. They didn't even give us any sides to even measure. It's not similar. So we're done. Are there any questions?
Can we work through number 5?
Let me see what it looks like so I can give you some hints.
It's the same.
So number 5, so what you're going to do is you're going to draw them separate, because for me that's hard to see them. And then you'll be able to do the longs over the longs and the mediums over the mediums. And they share angle R. Does that make sense? Then you can mark R as being congruent, and it might be a side angle side. I'm not
but
sure.
one looks like a
If they're
triangle and
proportional.
one looks like a...
Oh, they're 2 triangles stacked on top of each other. You gotta picture, like, you know, when you draw a mountain, there's a mountain in front of a mountain, so you only see half of the back mountain. That's how this is. There's a mountain in front of a mountain, so you only see half the back mountain.
Like this one, Amy.
Oh, wait, so we're doing this tiny thing in the middle.
Yes,
Yeah.
yes,
I
yes,
was
yes.
trying to do the other way.
Very good. That's exactly what I'll have you draw it out, because it's hard to see them sometimes. All right, number 6. Questions about 6. I mean, no, we're going to do 6. find the missing length, you now know the triangles in each pair are similar. You're not determining if they're similar. Now we're going to do the proportions. You've been doing these before, but they're telling you what parts go with each other. They're telling you what goes with what. So, because you won't know which one's medium and large when you have a missing piece. So if I put 12 on that triangle, which is DE, or ED, right here, goes with TU, and TU is how much?
Is X.
Is X. And then if I put 10 over here, 10 is FE, which is ST, which is 5. There's 2 ways to do this. You guys can cross multiply, but I want you to notice something really quick. Do you notice that 10 divide 5 is 2?
Mm-hmm.
So you'll want 12 divide something that is 2. So what is X going to have to be?
6.
Do you understand? This will reduce to 2, so that one has to reduce to 2. But you can also do the cross multiply. That's 60 equals 10x. Divide by 10. X will still be 6. When you're doing these missing pieces, you can't do the long side goes with the long side, and the short side goes with the short side, and the medium length side goes with the medium length side. Because you don't know the question mark if it's medium or long or what. Last one, number 8. I put it on one like that one. They're on top, and it's hard to see, so I'm going to separate it. Did I cut off some of it? Does it tell you what's congruent to what? It does not. You just have to just know. All right. So here we go. I'm going to draw that.
This is all the sides though. So.
And then that one as T and L. T goes together with T. All right. I'm going to change the color here. My purple triangle and my blue triangle. X over what?
60. Wait, what?
Wait.
Oh, that's Heidi likes to do it that way, doesn't she? You like to do one triangle on one side and the other triangle on the other side. Is that correct? I'll do it both ways. Okay, so I'm going to do the, back up. I'm going to do the purple, which is this, that's X here. This is 20 here. This is 24 here. And this is 60 here.
No, that's not X. Oh, wait. Okay, I see what you're saying. Yeah.
See what I'm doing?
Yeah.
Okay.
The other one was different.
So Heidi likes to do purple on one side and blue on the other. Like one triangle on one side. And then I'll do it that way, but I'm going to do it the other way also. Okay? So I'm going to do X over 60 because that's this first triangle here. That works. So X corresponds with what on the other triangle?
20.
Yes, good. So then we only have one thing left over, right? And that does go with the 60, 24. For those of you who like to do it a different way, you could do it X over 20 because they go together. One triangle and the other triangle. And then since we started off with X, we have to start with 60 and 24 on the other triangle. Notice that I just flipped.
Wait, don't we have to do all 3 sides since this is the side, and we don't have an angle?
They're telling us that this is congruent. Excuse me, it is similar, I'm sorry. So instead of the 20 over 24 though, you could have used 45 and
50?
18. Oh, but I'm not doing that right. So instead of using...
I got 5. I got 50.
I got 50.
You got 50?
Yeah.
Oh, that's where you got the 50. All right, do you understand how you could have used the 45 and the 18 instead of the 20 and the 24? Or the 60 and the...
Yeah. I got 50.
Okay, so So, Brett, which way did you do it?
I cross multiplied.
This one?
Yeah.
It doesn't really matter. So you got...
No, I didn't. I cross multiplied cross multiply x over 20
Okay.
equals
Yeah, that's
60
what I
over
did.
20.
And, then,
That's what
and
I
really,
did
you're going to
last.
get the same thing, right? Because it's going to be 24x, which is going to be 24x.
Yeah.
And then you're going to get 120?
1200. That's what.
Ooh,
I did
you're
the
right,
wrong
you're
thing.
right, you're
That's-
right.
That's why I got 5 instead
You're
of
right.
50.
You're right. Divided by 24. Is that 50?
Mm-hmm.
Yeah.
X equals 50. All right.
I have a question real quick.
Good. Yes, sir.
On the past lessons,
Mhm.
some of the answers were decimals and some were
Yeah, that was
fractions.
awful.
And what?
And I would always put down like a fraction or a decimal, and it would be like the opposite, but it'd be
I
wrong.
would
And
just
it was
put
not.
both
Was it
because I
cannot?
never
Maybe it
knew.
wasn't consistent with the thing
It
I'd said.
wasn't.
I will do a better job at looking at because I think I can click little buttons inside when I make your assignments, and I might not have been putting the integer instead of decimal.
I just put
So-
both down because every time I would look, I would have the same problem. So I just started.
I
writing
always
both down.
I always wrote mine as a fraction, and then whenever they did a decimal, I just divided out my fraction
To make
and
sure it
the
was
same
right.
thing,
Oh,
then it-
when
Okay.
you look at my quiz, that's why I'm gonna have like 2 answers circled because I did fraction and.
Let's go to the next one. All right. Now we're going to solve for x.
Wait,
So we have to do the same thing, but there's going to be an x involved instead of just numbers. It's going to tell us the proportion up there for the similar
We had
triangle.
X involved up here in 8.
Looky there.
It's the same thing.
Oh, you just made your own x. This will be like a x, like x 14, x
Oh,
plus 3. You
gotcha.
see the difference?
Yeah.
All right. So it says that I might do it Heidi's way. This time the 8 and the 13. What goes with 8 on the other triangle? Is it the 24 or the 14x minus 3?
24.
How do you know?
Because it's longer.
Because it-
The two longs get
like-
together and two short.
Well, I'm going to go by the words of the FT here. FT goes with FD. So that's how I'm going to make sure. FD goes with, so it's 24.
Oh.
Do you understand? You did it.
Yeah, I did it right. I just wrote it wrong.
Okay.
But I did it right.
14x minus 3.
No.
I'm going to let you solve that one on your own. The algebra's not the hard part. It's getting up the proportion that is. I'd like to move on to 12 if we
Wait.
can.
Please.
3.
Oh, did you?
I'm still writing it down because I wrote it wrong.
He's a very speedy algebra guy.
Did you get 3
I can do algebra. I just have
I
to
got
write
3.
the whole thing out because my dad
There's
made
3.
me.
So maybe we should do it together. All right, here we go. I don't know what 8 times 14. Can someone help me with that?
Wait,
112.
Yeah.
X minus 24. And I don't know what 24 times 13 is. Can someone help?
312.
Is that true?
Yes.
Okay, I'm going to add the 24 over there, which will be 336, correct?
Yep. Divided
That's what I
by
got.
112 is 3.
It's 3.
Oh yeah. And
That would be it right here.
Yeah.
I'm just gonna do this
That's what I got.
separate and then see what.
That's what I got as well.
Okay.
You know what? I'm just gonna copy what's up there.
Oh, no, you won't. Look like this.
Don't erase it. Don't erase it. I know how to do it. I'm just behind.
It's okay.
You're fine.
You're fine. You're going to do it, and you're going to... Yeah, then we can just put a little star next to it and say finish.
No. I don't work that way. I go home and I'm like, what did I just do? Why did I do it that way? And I have to erase it and do the whole thing. Not always, but most of the time.
All right, let's move on to 12. They did not give us a proportionality statement to tell it what's proportional with what. So if I do it, I'm going to call it the Heidi method. I like that. 10 over 14, that's on that small little triangle on the inside. If you can't see this, you might need to draw it in 2 pieces. But the 10 is going to go with the hole over there. The 10 on this side is going to go with the hole over there, which is going to be 65. Wait, where's the x?
7x.
7x.
13.
Is it not on my? It's not on my board, right?
No, it's not.
Oh, it got okay.
I was talking to her. No, I was
That's
looking.
7x
Okay.
right there, right?
13.
Brett is so fast.
Is that right?
We'll
I don't know.
figure it out after we finish.
That's 7x, right? Okay, so then we're gonna go
That. No.
65 over 7x. Is that the proportion you set up, Brett?
Yes.
Yes.
I got that.
Okay.
That's what I got.
So I got 70x, and I don't know what 14 and times 65 is. Can someone help
14
me?
times 65 is
910.
I'm going to pause for a quick moment.
Wait, so
I
what
got
is the
15.
answer?
Oh, she's ahead of me. Oh, good. Okay, I was afraid. I was divided by 70, divided by 70. So in my calculator, I only need to put a 91 over 7, and it goes in evenly.
yeah.
How many times?
Yeah. 13.
13.
I'm
Okay.
done before you for one.
It makes sense it would have something to do with the 3, because 7 times 3 is 21. That would give us the 1 and the 91. Questions about all this?
One question. Does it matter which way you put these?
No, that's a good question. On number 12, did you set up your proportion this way?
I set up the same way you did because I was behind, so I just wrote the whole thing down and then just went through it.
So but you could have done it differently.
Well, I
As
was
long
talking
as the
about
cross
on
multiply
10.
gets out the same.
I was talking about 10. If I did the 8 over 24 and then the 13 over the 14. X minus 3.
So I did it the Heidi method, but I kept everything in one triangle together. But you don't have to. You can go the 8 with the 24, because your cross multiply is going to get us the same thing. This times this.
Well,
Gives us
I
the
did the
six.
same thing that you did because.
Oh,
Yeah.
oh.
But I was wondering if it was okay if I did it my way.
Yes, definitely. As long as the cross multiply is the same when you're all done. Yes.
That's
Okay.
a scary number.
13. You're already.
Well, you were talking. Might as well be working.
All right, let's look up here real quick. Look up here. We're going to be done with this one. All right. There were 3 ways to prove that that we learned today to prove triangles are similar. We did.
Give me my pencil.
All right. There were 3 ways that we learned that triangles are similar. We have angle. That's the simplest, best way. I think simplest is best. But then if you can't, then we can go down here for side, angle, side, and side, side, side. Questions?
No. I'm not laughing.